Hello everyone, let's talk about the periphery, small p periphery. And so that is the higher level, or we can say the user interaction smart contracts to uh, uh, calculate and interact with different swap p pairs. So let's start with the interface first. And as we have go through the interfaces for Swappy core, so it's pretty easier to talk about here. So first is under the V1 folder, and there is one called II Uniswap V1 exchange, and that interface will currently that doesn't use in Swappy because this is for migration, as I said before. So that will migrate your old like for example the Uniswap V1 liquidity to the new Uniswap pair. And we did the change in the code here, Swappy migrator, but we didn't use it because we have nothing to migrate, right? Uh, so that's for the exchange interface. Second one is for the factory. It's also be used for to migrate. It will get the new factory. I believe we can uh, read it in the Swappy migrator later. Again, we have IERC20 interface, Swappy call interface, Swappy factory, and the Swappy migrator interface will inherit the Swappy migrator. Swappy pair interface, that's very important one. We will use it to do the swap means burn, etc. And Swappy router 01 and 02, it introduce lots of functions. Let me introduce because it's important. So first is add liquidity. That means I add the liquidity to the Swappy pair. So the first is token A, token B, for two tokens representing the pair, and the desired amount of token A and token B you want to add liquidity to the pair, and the minimum amount to A and B, because when you do the at the liquidity, as we mentioned before, what we want to exact is the 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 ratio between amount A and amount B. The the can be the same as the ratio between the reserve 0 and the reserve 1. If in that case we won't waste any liquidity, when we calculate the liquidity in the Swappy core, we take the minimum of the two, right? So we want to do the perfect ratio for amount A and amount B. But when you send the transactions, there are many transactions before you. Like for example, someone swap, right? Someone did some swap, the ratio has changed. So you got you you won't get a perfect ratio between amount A and amount B, and you won't get a perfect liquidity amount. So we have a minimum to cut it. So if is the desire is not expected, there is a minimum to add it. And two is the liquidity, the minted liquidity destination address. And deadline is that what I said. So before you execute your transaction, someone did some swap. And so if you want it happen, you must set some timestamp as a deadline. So when your transaction is executed, it won't exceed the deadline you expected. Second is a liquidity ETH, which means one of the tokens is native currency. So in Conflux, it is CFX. So if it's a CFX, it must be a payable. So one of the token is native currency. So must be this function must be payable. And another is the same, like amount token desire, amount token min, amount ETH min. And the remove liquidity is the same thing, and same variable, and the remove liquidity ETH is the same. And for with permits, as we said before, we have a signature to help to approve. So the sender of the function is a difference for the different from the address 2. And remove liquidity with permits, same. And the remaining is for swap. So there are several modes to swap. So you can give a fixed amount of token in, and you get variables various amounts of the amount out. You can also given the exact amount of the token out, but you should give enough of token in. And here is swap exact amount of CFX for tokens, or if you get a exact amount of CFX, and you can get you need give enough amount of token in. And also, if you want to get the CFX, you can give a exact amount of token in, or you want to use CFX to any amount of CFX, but you want get exact amount of token out. So there are different purpose to swap. So there are several functions here. And quote is very simple. It's a read-only function. Read-only function. It just you give amount A and reserve A and reserve B, and he just calculates the reserve A, the ratio between reserve A and reserve B, and you give your amount B based on your amount A. So just calculate the price. And get amount of out. These four get functions is used to do some, like, for example, we can say is a fake swap. So you get you set the amount in and reserve in and reserve out. You will get the amount out. And you want to give amount out, you will get amount in. And also, the pairs can be chained. So there is a path, like for example, you want to swap A to C, and you want to swap from A to B to the C. So the path is A, B, C, and you give a given amount of amount in, and you get the so in the medium you give so the return will returns the how many tokens for B, and that amount of B will be transferred to the final swap, and you will get the final amount of C. So you will get two values in this array, and it's the same. Get amount in is the same as the get amount out. Just different. You want get a desired amount of amount out. So that's for the router 01. And there are more functions. You can take a look. So there is a newer version. We call it 02. It's inherited from 01, which means it just inherited all of functions from 01. And besides those functions, they can do some fee on transfer, remove supporting fee on transfer tokens. So these 5 functions are not used in the Sloppy front end. But if you are interested, you can take a look for the implementation in the Sloppy router. And under the libraries folder is the first is the safe math. We already know it. And Sloppy, and next is Sloppy library, which is a pretty important one. It defines the quads get amounts out, amounts in, amounts out, amounts in, and some help functions. First is sort tokens. We will sort the smaller one as the first one, right? Token 0 is the smaller one. Token 1 is the bigger one, bigger address, right? Larger address. And then pair 4, which is I mentioned before, you will calculate the contract address which the Sloppy factory created. So you will remember the create2 opcode, which is used in Sloppy factory create a pair. So first it will sort tokens. So token 0 is smaller, token 1 is bigger, and he did the same thing and do the encode the Unicode hash and pack the token 0, token 1, and the factory address. So after do the SHA 256, you will get the correct pair address. So why it is correct? This is the mechanism for execute the create2 in blockchain. So if you're interested, you can check the Conflux chain network code, node code. You will see the create2 implementation is the same as this, and the Unicode hash is the 1 I mentioned before. So swappy pair has a unique code hash, which is the one in swappy factory. It is the creation code of swappy pair. So this hash is will be used in blockchain node to calculate the pair address. So here is just do the same thing as the blockchain node. So this function will calculate the swappy pair address. So if you just remind if you like did some change on swappy pair code, the creation code has changed, and you need to get the correct initial code hash from swappy factory and put it here, and to make sure the pair for function is correct. And next is get reserves. So you use just want to invoke the get reserve functions in swappy pair. So they just use factory token A token B to calculate the swappy pair address and wrap into a swappy pair interface and invoke get reserves, right? And sort it by token A and token B. Quad is a pretty simple function. You just calculate, as I said, just based on the ratio between reserves and calculates the amount B. Get amount out and get amount in is internal functions which will be used in the get amounts out and get amounts in. So let's read the last two functions first. So for get amounts out, so we have a amount in and the factory, right? Swappy factory and the path. First, we will because we use a get amounts out, we need start the from 0, right? From the past 0. So we get we use get reserves, get the reserve in and out, and invoke get amount out to calculate. For example, if we want to A to B to C, we will calculate from A to B and get the B amount. And next iterations, we will get amount of C. So amounts will be the return will be returned, and there are two values. There are three values, and the first value is just amount in of A, and the second value is the B, and the third value is the C. And it doesn't mean you can get the amount of B. Here is just show the median value of B. But finally, if you want to do the swap, you only get the amount exact amount of C at this moment. And get amounts in is similar but a little different. It will start from the end, right? From BC pair and invoke get amount in. Because we have a final the final amount of C. So from C we can get B, and from B we can get A. And the amounts is also follows A, B, C amounts. So it doesn't matter. You don't need care about the order of these two functions. Is the same path, is the same order of your path A to B to C. So let's see what happens for the get amount out and the amount in. So for get amount out, as I said before, we have a fee, 0.25% fee. So whenever we insert amount in, we need subscribe that 0.25%. So in this calculation, you will see. So you just because it won't get some fractional points. So the final divider is the division is be done as the last step. So through these calculations, the amount in will be deducted by 0.25%, and then multiply the reserve out and divide by reserve in. Just calculate the same as the quad calculation to find the amount B. And get amount in is also an interesting one, because you have amount out and you still need calculate the so when you use amount out to calculate amount in, you need times 1 plus 0.25% to get the full amount of amount in, just plus. So in this way, you will plus 0.25%. So that's all the Sloppy library helper functions, and we will use it in the Sloppy router as well. And Sloppy article library, which is used by a third-party price article calculation. I'm not talking about this here, but you can check it. It's the same as to get the price based on the timestamp, cumulative price for token 0 and token 1. If you're interested, you can look at the example article simple to see how is that going. But normally, if we want to check the instant price is always used, we just do the quote. All right, and the migrations, as my typo last time, this is for travel and you don't need to care about it. And that's for the sloppy migrator. It will help to add the liquidity. So first remove the liquidity from the old V1 factory and add liquidity to the new sloppy pair. So that's for the migrator. And sloppy router is the one we need care about. So first, sloppy router is in here to 02. As we know, the 02 is in here to 01. So it just include all of the functions. And sloppy 01 is just inherited from 01. So what we are care about is just a sloppy router, and it is also the one we are using in the sloppy in Conflux network. So first we define the factory and WETH. WETH in this case is the wrapped CFX. So CFX is native token, and we want to wrap it into a ERC20 token, which is compatible, will be compatible with in the sloppy pair. So this address, or we can wrap it like whenever, like whenever the user send the native token CFX into the sloppy router to do the swap, to do the add remove liquidity, we will help them to wrap it and send it to the pair. Or if you want to swap out or remove it, we help to unwrap the unwrap the WCFX and return the native token. Also, there is a modifier, which is one I mentioned. So the modifier will be added for some functions with a deadline variable. So it just require the deadline must be greater than the current timestamp. We did a constructor to just assign these two values only. And here is the receive fallback functions. So anyone can transfer, transfer any so the message so it is just only accept the CFX will fallback from the WETH contract, which means the sloppy router helps us to unwrap the token, unwrap the WCFX. So first, let's talk about the external public functions. We have the arguments here, as I mentioned before. So first, we will add the liquidity with those functions to calculate. So so these functions won't add liquidity actually. It just calculates the amount A and amount B, the exact amount A and amount B. Make sure it has a perfect ratio and the sloppy pair has enough yeah, just make sure it has a perfect ratio. And then we did calculate the sloppy pair address, and then we should send the amount of the token to the pair. And then we did mint. As I said before, before we do mint, we need to transfer all of the tokens to the sloppy pair first, and then you can do the mint. So in terms of the internal functions, first, if there's no, it doesn't exist, we this function will help to create a pair. but it will take a lot of gas actually. And then we can get reserves, reserve A and reserve B. And if it's zero, so it doesn't matter of the ratio between user input, right? Because there's empty here, you are the first one to add the liquidity. If there are some reserves, we need to calculate the price, the instant price based on at first calculate amount A desired as the input to calculate the optimal perfect amount of B. So if it's smaller than that's perfect. So we will cut it from desired to optimal. So, but sometimes the amount B is greater than desired. So we just do it reverse. So we insert amount B desired to calculate optimal A, and also cut it as from desired to amount A. There's only these two cases, and it won't get error from here. So in this way, we know it's the amount A, amount B are the perfect ratio before we add the liquidation. Just help users won't lose any liquidity. But in terms of the swappy pair, swappy pair doesn't care about it, because as long as the K doesn't decrease, is any amounts are welcome to receive. And here is a liquidity ETH. So first you will get some message value right here. Message value. So it's the same thing. So calculates amount token and amount ETH. Use the same function. The only difference is we need to wrap the amount, the perfect amount ETH, to wrap it into WCFX, and then transfer the perfect amount of CFS to the pair. It is a difference, different functions between the ERC20 token. And then and then after that we will do the mint. And if there's the massive value sometimes will be greater than amount perfect amount ETH, it will help us to just refund it to the message sender. And next is remove liquidity. First, we will calculate the pair address and transfer the liquidity to the pair itself, as we said before. And so I said before burn, we need to send the liquidity, and the dangerous steps is these two steps are separate transactions. It just someone can burn for him before you did burn. So after send the liquidity, you can just simply burn it, and you will get back amount 0 and amount 1. But actually, these two amounts will send to swappy router first. and then my bad. It will burn to the target address directly. And after burn it, we will calculate the amount in, compare with amount in, because the calculation is under the swap pair instead of swappy router. So it will check the amount AB is reached the expectation from the users. If doesn't, all of the steps will be reverted and the transaction will fail. And for remove liquidity ETH, we will first, because the pairs has the wrapped CFX, so you can just simply remove liquidity first, but the target address might be set as the sloppy router address, and the sloppy router will transfer the token, first ERC20 token to the target address, and it also help us to unwrap the wrap token with the returns amount of CFX, and then transfer the CFX to target address. And remove liquidity with permits is the functions for the we will use the permits function. So you will approve so message sender will approve the address this to do some to remove the liquidity. And after approve it, we can help him to remove the liquidity, and all of the tokens will be sent to the address. And it's the same thing for remove liquidity ETH. And this is for the remove or add remove liquidity supporting fee on transfer tokens, which is not important one, but you if you are interested, you can take a look to see what happens here. You don't need to implement these functions, but it's it's the same, pretty similar with the remove liquidity, but they just do some fee on transfer token. Yeah, and so next is for swap. So let's talk about the external function again. The first is for a given exact tokens for tokens. So we need to specify the exact amount of the token, and the path, and the deadline, and your minimum expectation for amount out. Here we use modifier ensure deadline to make sure the transaction will not happen before after a deadline. And first we use a get amount out to calculate the amounts, and then we will transfer from path zero to message sender. Right. Yeah. sorry. Is from message sender to the pair of pass 0 and pass 1, and send the amount to the to this pair, and the token is pass 0. So this function looks like something like the starting point to to trigger the whole path, and then we can do the swap. So in terms of the swap internal functions, we have the amounts, path, and to target address. So you start with the first one, right? Start with 0. So first we calculate the token address and and then sort the smaller one and the bigger one, and then we get the 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 amount out, and then based on the 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 which one is smaller to calculate amount 0 out and amount 1 out. And then we will check the target address, because it is in the it is the chain. So the last target is, the last swaps target is the actual target address, but in the medium is just you need to find the output, and you need to find the next token pair address. So for example, you want to A to transfer B, transfer C, and transfer to address. So each target is the B, C, and 2, right? So here is calculates the actual 2 address for each swap. And then they have amount out and amount 1 out, amount 0 out and amount 1 out. They can do the swap. And here we just hard code it as data is 0, so there's no swappy call there. So in this way, we can swap one by one, like one pair by one pair, and then transfer swap all of the tokens and get the final tokens. So after do the swap, the 2 address will get the final amount of the end of the past tokens. So if we want to give in the amount out, so here is a little tricky way. So if we still want to invoke the swap internal function, so we have to use get amounts in, get the first amount we need to insert, and then we did the same thing, transfer the amount 0 into the first pair, and then did the swap. So the next for swap for the related to CFX is a same way. We have to so if we want to swap ETH, we need to mark it as a payable and help it wrapped into a wrapped CFX. If we want to get the exact CFX, we need help to withdraw it. And also the target address will be changed to address this when we invoke swap internal function. And then I swap and transfer CFX to the to address. So these functions is the similar. And also we have a swap supporting fee on transfer tokens. If you are interested, you can look at it. And there are you can also involve the get amount out and amount out in here. It's also in this contracts interface. It's also easy to do it. So that's for the sloppy project. So it contains the sloppy core to create the multiple pairs, and the sloppy router will help users to determine the optimal amounts in and amount out, and also help users to get the exact amount when the users do the swap. So these two are essential to run the whole sloppy program. And I just recommend you could play with these two GitHub repos and try to use it to run some tests as mentioned here, and try to run the truffle, use a truffle tool to play with it, because you will implement the project with truffle or hard hat. It's easy for you to practice truffle and hard hats in these two GitHub repos, and easy to implement your projects. That's it. Thanks.